estimated start time. Oh, it's 10. Boom, there we go. This is the note well. You're in the IDR working group. If you were hoping to be in another working group, you picked the wrong one. This is the note well. This is the last time you'll see it this week, I hope. But it's just as important as it was on Monday or Sunday or Saturday. So please note it well. We are going to hold the rest of the shares slithering, slides, for the end, and get through the technical content first, and sort of with the intention that then if conversation happens to run long on the main thing that we're going to cover during our part is charter stuff. So if the conversation runs short, great. If the conversation runs long, well, we're not running into anyone else's time and we don't have to cut it off. So that, yep, we have an agenda. It's pretty much like the agenda we posted before, except we had to slide one thing from Wednesday onto today, but we had enough time, so that's okay. So I think we have Ketan on first. Okay. Your slides are live. I don't know what to do.
You knocked out the power just a moment. Oh, no power. Yes, it's okay. I think it's fine. Yeah,
Blue sheets have already been started. When the blue sheets get to the back, please circulate them back to the front. We'll run a second time.
Oops.
What now? Oh, we lost that. Okay.
We lost that. Is that the one?
What's the magic email address that you're supposed to email for technical assistance?
Okay, this one's up.
Yeah, so we have a screen over there. It's not ideal. I'm emailing support.
Is the next one working?
Yeah,
next one is
yeah, that's fine.
Okay, let me go find the.
So I just emailed this.
Okay.
Okay. Okay. Okay. Good morning. This is an update on the RFC 7752 draft, which was first presented in Prague. And I would like to point out that Stefano Previdi's affiliation is not correctly mentioned in the slide. It should be Huawei. So to recap, BGPLS has been widely implemented and deployed now. The BIS draft came about before Prague to clarify and update on certain things that I would say we have learned from the development and deployment experience. Some of the key things which the draft clarifies are on the slide here, and all of the changes are mentioned in the appendix in the draft itself. This draft would actually obsolete RFC 7752. Got some good feedback and inputs from the working group members on various aspects, and we hope to continue to incorporate and update it as we go along. So focus on the Okay. So the updates in version 1, it's, the key thing is, these are the key updates in version 1. One of them is that the RFC didn't actually talk about or describe how, in the case of OSPF, the LAN subnet would get advertised via BGPLS. So this has been clarified. It's to be done with a prefix NLRI that is originated by the DR or the pseudonode. Based on feedback, there are some changes in the private use code point space and other minor editorial changes to correct clarify. An IPR, which was declared on RFC 7752, has also been applied to this document. Adrian has filed that. In the remainder of this presentation, we wanted to get feedback from the working group on a few key elements that we have been discussing offline with some of the members. The first of that is regarding ordering of TLVs in the BGPLS attribute. RFC 7752 had this exact text which says that for the NLRI part, and to handle unknown TLVs and maybe unknown NLRIs, all TLVs must be ordered, in ascending order. And also, I mean, there is more text on the content as well when there is two NLRIs of the two TLVs of the same type. Now, some implementations have, kind of interpreted this to imply that TLVs in BGPLS attribute as well must be ordered. The BIS draft version that's posted had the text saying that TLVs need not be ordered in any specific way because it's probably not necessary or required. But we've got a proposal to change this text to say that the producer has to sort it, but a receiver should not consider the TLVs, consider attribute as malformed if the TLVs appear in a unsorted order. So this allows implementations to, or rather recommends implementations or the originators to send in a sorted order, but does not consider malformed on the receiver. So this is one thing which we would like to get feedback from the group members here and on the list. And based on that, we would, right now the proposal is to go and update as we discuss right now. The other key part which we need to discuss and share is this new text been added in the BIS draft to describe a problem which probably has and might have been overlooked by developers or people deploying BGPLS, but at least some folks have discovered or found this out over the years. And this is in a topology as shown in the diagram here, where if the BGPLS producers continue to advertise the topology objects, the NLRIs, as they are in the IGP LSP database, then it's possible that in certain certain configuration, for example, when we are distributing via route reflector, or when the consumer application is getting multiple feeds, that it may get a wrong or inconsistent topology view. And this is because the BGPLS propagation happens on BGP best path, which is not really able to determine which LSA or which information is stale and which one is the current one. So there have been two options that we'll go over today. The first option is what's currently proposed in the draft. That option says that BGPLS producer should withdraw link state objects associated with nodes which are determined to be unreachable in the underlying IGP computation. So how this works is that IGP running on, let's take example of R2 here, IGP running on R2 as part of its IGP processing today, marks the LSAs or LSPs of R4 and R6 as unreachable after running its SPF. When this link fails between
Can I ask a
R5.
clarifying question?
Yeah.
Should I imagine that link A0 doesn't exist?
See in this picture, A0 is in area 0. Okay, it's a OSPF thing.
Oh, I see. Okay, thank you.
Yeah, and the others are in area 1. So, yeah. And so in this case, the proposal is that R2 actually withdraws the BGP-LS NLRIs corresponding to whatever was originated by R4 and R6 because it's unreachable. We don't know. They may be stale. The nodes may not be there anymore, so on. And it's the other way for R3. So what R0 learns from R2 and R3 is really, it learns from R2 the node objects of R1 and R5, and from R3 for R4 and R6. So there won't be any stale LSAs or LSPs in the BGP database, that is the BGP-LS RIB. So this allows the BGP-RR and other BGP routers on the propagation path to just follow the BGP best path process. Now in this picture, we have just the R0 here as a route reflector, but there are different propagation models, some of them which are described in the draft. So, I mean, you should generalize this for a case where the propagation may be even happening over a eBGP link within a provider network. The alternate solution which has been proposed is that the BGP-LS producer continues to advertise whatever is in the IGP LSDB without any reachability check. So everything which is in the LSDB gets advertised out via BGP-LS. And in this case, to account for this thing about stale NLRIs that we talked about, we need to really propagate all the paths or all this NLRIs information to the consumer. So in this case, if there is an RR in this picture, then the RR would have to do add path so that it doesn't filter out, let's say, a good NLRI. And then if there are other BGP propagators along the way, then they must also do something similar to add path. We also would need a kind of a originator attribute to be carried along with the BGP-LS NLRIs. So if it's a simple route reflector, this thing, then the originator originator ID attribute would suffice. But they are not carried over eBGP, so we'll have to maybe think about how to do that. The consumer of this feed would get multiple copies of the same NLRI information, and then it's on the consumer application controller or a PCE or any other thing to actually figure out what's the which ones are really the fresh ones and which one are the stale ones. So in order to do that, what the consumer would have to do is like an IGP kind of a processing, where for whatever topology it receives in this picture from R2, and it knows that it is from R2 because of this originator thing that is carried, it has to run its IGP SPF on the topology. And then it determines that, okay, for R2, R4, and R6 were not reachable, so I probably cannot use it. Similarly, yeah.
A-cylinder Cisco systems. I just don't understand this. The person who's originating this in BGP will do this. You could, the API could handle this all internally. Because OSPF or ISIS knows what is and isn't reachable.
Yeah.
And so it doesn't have to be in the draft, right?
Yeah, so it's so that was the first proposal that we discussed, where the IGP does that, and yeah.
So
So
Okay, I guess I don't know why you do it any other way.
okay,
I-
so
I-
we'll go through. Yeah, we'll go.
I do have a clarifying question on this one, if I may, which is the bullet that says consumer gets multiple copies of the same NLRI. That's not unique to this solution, is it? Like even on the previous slide, you know, a consumer that's consuming from both R2 and R3 would end up getting multiple copies of the same NLRI, isn't it?
It wouldn't, because the R0 would select best path. So
Right,
in the
but what I'm
previous,
suggesting is that if the consumer is at location R0 instead of
yes,
behind a router
yes,
platform.
in that case it is, and it would be an implementation aspect on that device, how the BGP and the consumer API is. So you're right, it could receive multiple copies, or the implementation could run BGP and best path and provide one copy. So both things are possible. Yes, it's an implementation aspect. So after running, so consumer learns the topology from the point of view of R2, and then it runs this IGP SPF to determine which are the valid topology set from R2's point of view. Similarly, from R3 point of view, and then these together can be kind of consolidated to get actual topology view of the network. So this is a comparison that we've come up with on the pros and cons of the two options. So for the solution A, the pros are that we don't need to change the BGP propagation or the path computation rules. We don't need things like add path to be mandated, or the new originator ID kind of attribute. The pros of the solution B is that it actually provides a complete LSDB view to a consumer application. So this is something, depending on the application, this may be something that is required. The cons of the first proposal is that, yeah, it doesn't provide the complete view. NLRIs for nodes which are unreachable would not be presented in this case. So it may be something that's okay for controllers or application, like perhaps like a path computation element or a TE topology, this thing. But for other applications, perhaps like just like a LSDB view kind of a thing, that may not be a good way.
David Lampeter, just to point this out, when you say it needs add path, you mean it needs add path and you need to have everything in add path.
Yes.
Yeah.
Yes. Yes. So add path and yeah. The cons of the the cons of the first another con is that we have this kind of what I think what AC was trying to talk about. We have this kind of a dependency between the IGP SPF computation and the origination of NLRIs. This is not something which was covered in the RFC 7752. Cons of the other proposal is this add path and the originator thing. We have to do that whenever there are scenarios where multiple views, or there are like most deployments may have redundant BGPLS originators, and in that case, this is kind of a requirement. It also requires consumer applications to perform this IGP thing that we talked about, to determine which are the fresh NLRIs and which one could be the stale. As a result of the add paths and route reflectors or eBGP routers along the path not being able to run their best path, which means we are sending a lot more information in BGPLS. And kind of a corollary of that is that whenever something changes, change that is propagated to all the controllers or applications, redundant stuff. So we wanted feedback from the working group on these two solutions, and how we would like to proceed further.
I'm from Telecom. I think the solution is more preferable because we think the Gprs should provide the real status of the underlying topology. I think the real status of underlying topology is more useful than the complete LSDB information.
Okay, thanks.
Okay, Jiedong from Huawei. Actually, I think the two solutions, actually they define who will be responsible for this kind of validation, whether the device should do this or the consumer will do additional computation to validate the information collected, right? So I think both has pros and cons, and
Yes.
we will consider which one will be the best for the both controller and the devices. And we will need to collect more information from our team to give the feedback to you.
Sure. Yeah. We don't have to decide here right now. I mean, we would wait. Yeah.
John Scudder, it occurred to me that there's one more thing that, I mean, I'm sure that we could go on and on with pros and cons, but one thing that may be relevant that I thought of as a con on solution A is, in the example that you projected, there were the right set of feeds to provide, fresh data from both sides of the partition so that the consumer still gets a complete view of the topology. If you imagine that the consumer is just getting the feed from, let's say, the left-hand side of the topology, or no matter what, you can always construct a partition such that the consumer doesn't get a feed from the other side of it. In that case, solution A, disappears information about the unreachable side of the partition. Solution B leaves that stuff around so the consumer is able to know, oh, there was some stuff that was in the topology. I can't reach it now. I think this sort of, drives in the same direction as solution B is essentially more general in that it exposes with as much fidelity as possible the entire LSDB toward the consumer at the cost that you noted, which is that the consumer has to be a little more sophisticated.
Okay.
And so we have to ask ourselves, are we trying to tailor this to one particular set of use cases, and does the consumer actually, need to be able to have that sort of simpler implementation? I guess the way I'm presenting my observation should make it obvious. I kind of prefer solution B, but it's just from a desire to retain generality when possible, not for any reason
Sure.
more specific than that. Thank you.
Yeah. So I think that's a very good point, and it depends on what kind of consumer application we are looking from point of view. So if we look at something like a path computation or a T engine, then the nodes which are unreachable for it cannot compute for them or consider them in the topology. So for those kinds of applications, it doesn't matter to have the LSDB view. Another thing which probably I should point out is that the BGPLS topology view is not like the inventory view of the topology. So I would expect applications and things who are working on that they have like some other mechanisms to have, okay, this is my actual physical topology or this thing. And the BGPLS is only providing, let's say, like more like the operational state kind of a thing. So it also depends on what the consumer application is expecting. So I agree that it's a lot of things are from the perspective of the application.
Sri Hari Sangli, Juniper Networks. I think I just want to add my perspective into this. Right? BGPLS, if you look at it, if it is a topology propagator, then it is different from consumer. So in that sense, consumer's job is to really get multiple copies and figure out what the right thing to do. And the BGPLS, is just a propagator of the topology. In that sense, solution B will be more generic in my opinion.
Sure. And just to clarify, we don't need to necessarily pick between A and B. I mean, technically both could be allowed and stuff like that. Yeah.
Andrew Stone, Nokia. Regarding the fidelity comment and essentially suppressing of information, we're already doing that today because sequence number is not propagated. So if we really want to say that we're trying to provide a full view of the linked state database, we should be looking at adding those attributes as well, which then causes an explosion of information, data passing, processing. So I think from the point of view that it suppresses data, it's a valid argument, but the cost of not suppressing that data and the computation required in order to satisfy actually making use of it is quite expensive, and I would question for what, right? Most consumers are looking at using BGPLS data for connectivity information, not necessarily linked state database information.
That's correct. I mean, I would agree with Andrew here, and it's an important fact to know that we do not have the ability to communicate sequence numbers, and an IGP LSDB without sequence number is kind of like blind in some sense. So I think it's thanks, Andrew.
Justin Siro. So I fully agree with Andrew's comments, and complexity introduced by solution B, I don't see the justification to do this compared to A, where it's cleanly you withdraw what you lost, and not sure controller really need to know about skip history. And there's other augmenting information that's coming from different places. So keep it simple, less bugs. Would be good.
AC Lindum, Cisco Systems, I agree. I mean, less is more. You know, give them what's reachable, not that's true topology, not what's there for another, that doesn't time out for hours, right? An hour in
Yeah.
OSPF and even longer in ISIS, right? So.
Yeah. Okay, so I think get a sense, but we'll continue this discussion on the email thread, and yeah. A couple of other things. One is on the Ayana allocation rules. So there has been some discussion on how to do this for BGPLS to make it simpler and faster. I think Adrian has posted a draft which tries to cover that. So we can see how to incorporate the changes, whether in this draft or that, we can work that.
And we'll also cover that in the chair section at the end.
Okay, thanks. So the next steps on this is some editorial fixes based on comments received from Adrian and some other folks as well. And I would request to give feedback based on your development and deployment experience, and we continue to do this discussion on the list and evolve the draft. But we'd like to ask for working group adoption. It's already
You actually
started.
are in the middle of working group adoption.
Yeah, sorry.
Your co-authors need to give us all the IPR statements.
Sure, thanks.
Okay, Jedong from Huawei. I have one more comment about this update. There's one thing, one change in this base draft, which is maybe inconsistent with the BGPRS EPE draft about the link local remote identifier in the link district cryptors. So maybe we need to take a look about that.
Sure. Could you share that on the list, and
Okay, sure.
we'll try to incorporate. Thanks.
Good morning, everyone. Charlie from Huawei. My topic today is a POS segment in BGP and BGPRs. So basically, the motivation is in SRMPRs, we have to insert a POS segment to identify SR POS because the packet comes to the egress that the egress cannot identify which the POS the packet belongs to. So we propose the SRMPRs POS segment in IETF draft Spring Amperes POS segment, and it is a IETF working group, Spring working group item right now. So similarly, we propose an SRv6 path segment in Spring Working Group as well. So in that case, in SRv6, the segment list may not be a good key to identify an SRv6 path, as the length of the seed list is too long and flexible. Yeah, so we create a new segment called the SRv6 path segment to identify an SRv6 path segment path. So in order to collect and allocate the path information, path segment information, we need some extensions in BGP and BGPRS. So that is what we have done. So first of all, we update the draft the IDR policy path segment to replace the previous one and called the IDR policy path segment distribution due to the name, because the name is too long and is unavailable to upload. So the second one is the BGPRS extension draft. So the main ideas is we add a new path segment sub-TLV under the segment list sub-TLV to identify an SR path. So that is the format of this TLV. I will not go into the details of this format, and please go to review the draft. And also we create some new sub-TLV to describe the bidirectional paths in BGP. First of all, the first one is SR bidirectional path sub-TLV, and the second one is reverse path segment list sub-TLV. Regarding the reverse path segment list sub-TLV, it shares the same sub-TLV with the segment list sub-TLV. Yep. So the main updates this time are that we add new calls from China Telecom and his Hua Nanchen, and we also adjust the comments from Shara Hatch, and we add Ayana allocations part, and also we add text to specify the path segment sub-TLV that can appear at two levels, which are candidate path and segment list. So that's what we have done this IETF. And let's do a quick review of the next draft. Basically, we did the same thing, right? So that is a format, and this is the same for the extension in BGPRS, and that is the update. And next step, welcome to review, and your comments are always welcome. And by the way, we think we are ready for working group adoption, so we request for working group review and adoption.
Any questions?
And if you haven't already sent that adoption call to the mailing list, please do so.
No yet. Okay, I will. Yep. Thank you.
Hello, everyone. I'm Zhu Yongqing from China Telecom. My presentation is PathMTU in BGP and BGPRS. As we all know, in traditional MPLS, the PathMTU can be signaled via signaling protocols like RSVPTE and RDP. However, there is no additional signaling to establish segment routing passes, so the SR tunnel cannot currently support the negotiation mechanism of the PathMTU. When seeds are inserted into the packet will be dropped in IPv6 or fragmented in forwarding, since the packet size may exceed the PathMTU. As for China Telecom, when we deploy the leased line over multi-domains, we usually need to know the pass-MTU. If not, the customer package size may exceed the minimum MTU among the nodes along the path. Then the packets can be dropped or fragmented. This will cause lots of problems. Thus, we propose the two drafts. The first one is draft 2 IDR BGPRS pass-MTU, which specifies the extension to BGP link state to carry maximum transform units messages over link. The second one is draft the IDR SR policy pass-MTU, which defines extensions to BGP to distribute pass-MTU information within SR policies. Let's have a look at the first draft. This draft defines a new sub-TLV to add to the link attribute TLV, which we call PMTU TLV. Since RFC 6326 has defined a sub-TLV to advise the MTU of a link. In this draft, we reuse the TLV. The format of the sub-TLV is as shown below. Whenever there is a change in MTU value represented by link attribute TLV, BGPRS should be reorientate the respective TLV with the new TLV with the new MTU value. Then the controller calculates the pass MTU. The second draft defines a new sub-TLV, a new segmentless sub-TLV in as a policy. As draft IETF IDR segment routing T policy defines the SR policy structure as per figure 1. Each SR path has its path MTU, so PMTU TLV should be inserted into the segment list sub-TLV. Let's have a look the format of this TLV. The length is the total length of the value field, not including type and the length fields. The reserved field is 16 bits long and must be set to 0 on transmission and must be ignored on receipt. Path MTU is 4 bytes value of path MTU in octets. The value can be calculated by central controller or other devices based on the information that learned via IGP of BGPRs or other means. Whenever the path MTU of a physical or logical interface is changed, a new SR policy with new path MTU information should be updated accordingly by BGP. Comments are come. Shall we sync up the path MTU TLV format in SR policy with the one in BGPRS? Thank you.
Just answer. Who would be the consumer of this information? PC, controller? Why would you distribute this?
Pardon?
Who is the consumer of this information? Consumer, who is going to use this information and for what purposes?
Yeah, I suppose it should be the controller and the ingress node.
So we are already distributing MSDs for both SR and SRv6, and they're taken into consideration by PC when they compute a path. Do we need this additional information? How it's going to interact with MSD data? How's PC going to decide to compute number of seats versus number of bytes? How do you see this working?
It's like we have to get the information of this path MTU and then we update, install, or send the information to the ingress, such as within the SR policy. Then I suppose that we work and we can discuss this offline.
It looks like somewhat redundant given that MSD data is already there. We know exactly how to form full stack and what should be in it.
Yeah, that would be another option.
Okay, Zedong from Huawei. I think Jeff just mentioned the MSD is for the label stack depth, right? But here the MTU, link MTU is about the capability of the link in the transit, in the intermediate nodes, links in the network. So there's a different capabilities of the path.
You need to combine them, right?
Yeah, maybe you need to consider both when you encapsulate the label stack, right?
The interaction is unclear and seems somewhat complex. So if you could address it, it would be great.
Jeff Haas, I have two comments for you. The first comment, first one's more of a question. This is a problem for RSVP as well, but for links that are link aggregate groups, LAGs, sometimes one of the problems is that there are misprovisionings of MTU on some of the component lag elements. Do you see any way in your mechanism to show that?
Sir, I can understand.
I will take my questions to the mailing list.
Okay, thank you.
Hello, good morning. I'm going to present this document. This was presented in BEST as well. On behalf of Ron, I'm going to present this. Okay. For SRv6 Plus, this was presented in a couple different working groups in this IETF. Feel free to look into that presentation for more details, but just giving a little bit more details or very brief overview of what SRv6 Plus is all about. The one that is relevant for this particular group is SRv6 Plus gives you a unidirectional link path connecting between the two routers. And SRv6 Plus also provides you programmable instructions that you can send from the egress into the ingress to tell what the work can be done. And also this particular thing completely relies on the IPv6 data plane. On the other hand, BGP, the overlay with all the VPN services, has been going through multiple different tunnels, be it MPLS, IP, GRA, and things like that. So, simple problem statement. We all know about this picture. The thing that is special in here is the underlay is SRv6 Plus. SRv6 Plus introduces, like I talked about, multiple types of instructions. One that is relevant here is a per path service instruction, PPSI, as referred in this document. And SRv6 Plus puts this PPSI in the destination options header, the second destination options header that's in the IPv6 datagram header. And all the P routers in the network, they do not look into the into this header, therefore they are PPSI unaware. And the PEs use the service instructions for the basic or can use this PPSI information for providing the VPN connectivity. So the proposal is let's leverage what we have today, which is using the tunnel encapsulation attribute, a tunnel encapsulation to signal that you can establish a tunnel. And that means SRv6 Plus path is considered like a tunnel between the ingress and the egress. And the specifics of the tunnel encapsulation attribute is listed down here. We're requesting a tunnel type for SRv6 Plus. And all sub-TLVs, specifically the tunnel endpoint, protocol type, and color can be used to influence what gets into this tunnel. And some of the other sub-TLVs, as mentioned in the tunnel encapsulation document, are not needed, which is what I've listed down here. The special thing is what the tunnel encapsulation document talks about, which is the embedded label handling sub-TLV. It only talks about 1 and 2. This document introduces the value 3. Value 3 is explicitly saying that the ingress, when it knows that the encapsulation, when it knows the extended label handling value is 3, it's so that the embedded label value that is there, which is the PPSI, is to be put into the destination options header, right? So in other words, the PPSI can be treated like an embedded label in all the encodings that we have for the IPVPN or the EVPN NLRIs. Here's a couple examples. The document lists a few more, and then I got feedback. Forgot to remove some statements on the PTMP. Ignore that in the document. But the encoding is we are going to leverage all the encoding schemes that we have for the various NLRIs on the L3VPN or EVPN. Just that in the embedded label field, you're going to take the 3 bytes of the PPSI. PPSI is defined as a 32-bit. We don't need 32-bit. We just need the 24 bits, and that can be embedded into the label field for both the various encodings that we have with BGP. From a procedures perspective, let's take egress. Egress, the PPSI is associated with the forwarding table, which is what that is used for demuxing the S5 level. And PPSI is encoded in the embedded label we talked about in the previous slide. And along with this NLRI, which is I'm calling this SRv6 plus NLRI, the tunnel encapsulation attribute has to be sent so that you are signaling to the other remote BGP speaker that you are interpreting this in a SRv6 plus type. On the ingress, the PPSI is constructed. You get the 24-bit, and you're going to construct the PPSI actual identifier that is forwarded, that is programmed to the forwarding table in the SFib to say, here's my PPSI, and here is the prefix. And the nature of data plane is mentioned in the SRv6 plus document that Ron talked about. So it gets into the destination representative header. The P routers ignore it, and the PE receives it, figures out which is the final VPN that it needs to process the packet to going to the CE and things like that. Questions, comments, and then this is going to be more on the best. So request for accepting is not in this. Any other questions? Thank you.
Thanks. And just to, for those of you who weren't in BEST, correct me if I get this wrong, but the guidance from the BEST chairs was first, let's see what Spring wants to do with SRv6 plus, and then if Spring says, great, we're going to work on v6 plus, then they're like, yeah, this draft is completely appropriate for BEST, but they're not going to proceed with workgroup adoption until they know, sort of what Spring wants to do with the technology.
Sure. That's right, John. Yeah. Thank you.
Yeah.
Hello?
Wait,
Can you hear me?
are you there?
Yes, yes. Can you hear me?
Yes, we hear you.
Good, thank you. So good morning, everyone. Today I'm going to present SR pass ingress protection. Next page. So some of our critical traffic, real-time traffic, and live traffic may be transported by SR pass. For example, so we may have SR pass from a bank to New York Stock Exchange, and then this SR pass will be used to send a request for buying or selling stock. So when we use the SR pass to connect operation room and the doctor's office for support remote surgery and so on. As we can see, we need a protection for this SR pass. If this SR pass get broken, we can see that we may have a big loss. So next page. We have TLSPs. For TLSPs, we have end-to-end fast protections. For example, we have TLSP ingress fast protection, already have RFCs. We have midpoint protection for TLSPs. We have RC 4019. We also have fast protections for egress node of TLSPs. However, for SR pass, we only have a few individual drafts. These drafts propose some solutions for midpoint fast protection and egress fast protection for SR pass. We don't have fast protection for SR pass ingress node. So I think there's a need or requirement for provide fast protections for SR pass ingress node. Next page. Right now, BGP has already been extended for support SR pass or tunnel setup. We have BGP SR policies. So using this BGP extension, we can send information to ingress node of SR pass. So with this information, ingress node can set up a SR pass or tunnel. So it's natural and very easy to extend BGP to allow BGP to send information to a backup ingress node. And then with this information, backup ingress node can set up a backup LS pass. So as long as ingress node fails, we can very quickly to import traffic into the backup SR pass. So in this way, we can provide fast protection for failure of ingress node. So with this fast protection for ingress node, plus those proposals for midpoint fast protection and egress node fast protection, we have fast end-to-end SR pass protections. So what kind of information do we need on the backup ingress node to set up a backup pass to provide faster protections for primary ingress node? Next page will provide those informations. Next page. So in order to set up a backup path to provide fast protection for ingress node, so we need these informations. First, we need the information for backup SR path. We may need the information for primary ingress node. In addition, we may need the information for the service which is transported by the SR path. Furthermore, we may need the description of traffic which is transported by the SR path. For some of this information, we can we can reuse the SR policy. We just need a very small extensions to existing SR policies to just encoding all these informations. Next page. So right now we have a SR policy extension. So we just needed to have a small extensions to existing SR policy encoding. So here we just define SR pass or tunnel ingress protection sub-Tlvs. So all the other information is in the existing SR policy. So those extension just we here is in blue color, which is mainly is a SR tunnel ingress protection sub-Tlv. So under this sub-Tlv, we have a couple of sub-Tlvs, such as primary ingress sub-Tlv and service sub-Tlv. So next page. So for SR tunnel ingress protection sub-Tlv, so we have a flag. So this flag just indicates whether we will let the forwarding entry for backup SR pass, whether it's active or inactive. That's an indication. So in this sub-Tlv, we may have a couple of optional sub-Tlvs. So this optional sub-Tlv may include primary ingress node address and service ID or service labels. So we'll look those sub-Tlvs. Next page. So ingress, a primary ingress IPv4 or IPv6 address sub-Tlvs. So these sub-Tlv just contain either the IPv4 address of the primary ingress node or IPv6 IP address of the primary ingress node. So next page. So another set of sub-Tlv is a surface sub-Tlv, because we know SR path may carry some surface. So this surface will be identified by a surface ID or surface labels. So here we have a sub-Tlv surface label sub-Tlv, which contains 20 bits labels, which is used to identify a surface which is carried by SR path. So another surface ID, surface may be identified by surface IDs, which may be 32 bits surface ID or 128 bits surface IDs. Yeah, next page. Yeah, I think that's all about the SR extension, BGP extension for support SR ingress protections. So any comments and suggestions?
Anybody? If not, okay. Thank you very much.
So any questions? Cannot hear.
Waymo, we did not have any questions.
Okay, thank you.
Thank you so much for the presentation.
As soon as we find your slides, Jeff, you're up. Yes, you did submit them. It's a PowerPoint PDF impedance mismatch, so if you want to start talking, feel free, or if you want to wait for your slide, we're not in the queue.
I can get started. So I'm Jeff Haas. I'm here presenting for some of my colleagues, Raffle and company. And what we're going to see here is a relatively trivial mechanism for passing along colored labeled routes using BGP. The use case is with all of this fun SRTE stuff that we've been doing over the past several years. We have some needs to pass around information in a very simple mechanism to reach from one PE to another PE in an inter-domain fashion. And clearly we have all sorts of mechanisms that have been going around that work great for in AS. We have as examples, BGP-LS being used. We have cases where people are doing PSEP, BGP policy, SRTE, but the interdomain case is a little messy. And this is the point where I have to wait for stuff. As I mentioned, this is on behalf of Louis and Raffle. Next slide, please. So again, like I said, the big thing here is we're trying to provide a tool for end-to-end transport for stuff. Next slide, please. I can have clicker actually works. So as we all know, for SR TE type applications, color is the way we tend to refer to things. So an SRTE route does need interdomain treatment as well. Obviously, the intra-domain aspects are covered by a ton of drafts. I'm not going to spend any time in the slide deck discussing this. Next slide, please. That is the correct slide and has been mangled. Would you load the PowerPoint, please?
This is the danger with what? That is the PowerPoint. This is PowerPoint presenting on whatever they have on these Chromebooks. So
okay,
I can quickly generate up a PDF and upload it and blah blah blah. But
I will submit it at a later update for everybody to look at. The information in there's not terribly interesting. Let's go back to full screen. The diagram in question that we're missing is just simply a network that shows a interdomain component on the right-hand side, where you have route reflector in the middle, and you're exercising normal SRTE type mechanisms. We have colored routes, and we pass it to an AS on the left-hand side. At the AS border, we're passing around, the new labeled colored route. Labeled color unicast is what we're doing here. Next slide. And again, this is not terribly interesting.
This is why we normally PDF them. Sorry, we missed this one.
Unfortunately, I used the new submission tool, and usually it can auto-converts on its own, and it didn't do well. So something for the tools team next time. So the format that we chose follows the 3107 BIS draft that became RFC very recently. It's 8277. BGP labeled unicast, very boring. Normally you have prefix, which has labels at the top, and the actual prefix at the bottom. Use this for all sorts of BGP things right now. The thing that's changed is that we're going to next slide.
Hi, Jeff. It's Adrian. While we wait, did I catch you saying that the agreement of the colors between the domains had to be made?
How about we get to that in a second? Good question.
Okay. No, damn. I was trying to,
Excellent question.
Shall we sing a song or something instead?
Well, I will save the entire room by avoiding singing. My singing voice should not be heard outside the shower. Please don't request for songs.
Yeah, maybe I can ask another question. I see the network slicing is mentioned in one of the page. Yeah. Yeah.
It also completely ignored the fact that the Juniper business thing should be gone. It's just the PowerPoint template, so I apologize for that. So like I said, this is a very simple proposal. Labeled color unicast, we're just simply adding in a color along with the labels.
Right.
The position of the color is there to allow us to do things like wildcard on color, which is a application for some people's SR networks. The color value has got color value 0 has been reserved, as you'll see in the draft. The draft is very heavy on use case, and we realize the use cases will probably need to be trimmed down after working group adoption, but the whole idea is to get people socialized with some of the things that drove us to talk about this. The one thing that's a little bit on the interesting side is since this is covering SR cases, we realized, especially with IPv6 destinations, that the number of labels would probably outgrow the size of a single BGP NLRI with the standard 1 byte encoding. So the only other thing that's a interesting change in here is that we offer the flexible 1 or 2 byte length encoding that we use for BGP flow spec. Those procedures are well documented and gives us the ability to put on more SIDs on the stack if necessary. Next slide, please. So attribute considerations. So the remote next hop, and this is what you would use for the service routes that resolve over these things. Obviously, you match this based on a color community, just like we do for other SR purposes. We're not changing that. This is not interesting. Color extended community is the way we typically do this. We're generally recommending exactly one. One of the issues that we think needs to be brought up to best as a general item is a lot of these magic communities are not really well defined when they're multi-instanced. So we're trying to clarify that in the draft. For our specific LCU routes, we're saying the tunnel and cap attribute should not be carried. TE being the plumbing of favor of the day, we suspect that somebody will eventually come up with something that they want to put in there anyway, but this is what we're saying today. And in cases where you actually want to utilize this along with prefix SIDs, that is actually allowed. Next slide, please. So, okay, back up. Slide 8, please. There we go. So a question that we've received, and this was actually part of our discussions when we were trying to figure out what our favorite encoding should be. As we know, we're not, the IETF encoding spends a lot of our discussion time, but really the functional thinking is what we really should be discussing. So why not the existing tunnel and caps encoding? That actually carries endpoints, it carries colors, and the cable stacks. We can do everything in here. The problem that we have is that in terms of BGP propagation characteristics and how we want this stuff to behave on an interdomain basis, the NLRI key really needs something that disambiguate multi-instances of this. And since the thing we're trying to carry around and distinguish really is just color, we wanted to make this part of the key. And once you've done that, you've taken away a significant portion of the motivation for the tunnel and caps attribute. Now, of course, we could do other things to get that diversity in there. Could have a route distinguisher, could be add paths. The problem is we want something that gets carried interdomain, so we end up in this particular solution. And of course, we're not particularly set on any specific encoding. We just happen to think that for the use cases we're discussing, this probably makes the best sense. We're happy to take discussion on this. Next slide, please. And again, this is domain independent. This can be using for any tunneling technology at the other side. Could be SRT, RSVP, et cetera, et cetera. As long as we actually can carry the intent over there and express it in the color, and it resembles MPLS, LCU encoding works perfectly fine. And this is BGP. This means that as it crosses domains, operators get to be in full control of what they actually do. Next slide. So Adrian actually managed to bring up a question early on. What do we do about color conflicts? The current proposal does actually presuppose that we're going to have the set of providers that are using this technology agreeing on a color across things. This was the most contentious bit of our internal discussion with the people that are very much lacking operational exposure. The fact that operators can't agree on the value of 1 for sufficiently small values of 1 sometimes. And part of the discussion here was, what do we do if IETF decides that we can't agree on these things? This does probably involve some sort of middle layer. We have actually had a discussion that really color in an interdomain basis becomes a namespacing issue. Everybody internally is going to have their own color namespacing. The question is, can you carve out a space that you all can agree on for the things that you really care about being interdomain? The idea being that for multi-AS, you tend to have 2 deployments right now, 2 deployment strategies. The first one is it's really the same organization with multiple ASs, and therefore they can come to some sort of agreement. The other one being actual separate providers where the coordination does not exist. One of the things we can do about that potentially long-term, as I mentioned, we have options to put some sort of disambiguating thing on there. And that disambiguation, whether it's a route distinguisher, a domain distinguisher, pick whatever name you actually want to assign to the thing, allows us to potentially namespace the interdomain version of this color. So the interdomain red that you agree on across 3 ASs may locally map to your red, your blue, your green internally. And we did have had discussions about, we could do these sorts of things. But the thing I pushed them to do for the first version of this draft is, let's start with a simple case and see who stands up at the mic and says, well, you haven't thought about this. Well, we did think about this. Let's start with simple. Convince us otherwise. We do have a backup plan. But in terms of part of our headache here is scaling. The motivation for this, at least one of the easy motivations for the interdomain case, is network slicing, the topology that we failed to bring up. That's going to involve potentially the case with you're trying to provide endpoints for tens of thousands of endpoints in your system. And when you start scaling that out with stacks for each of them, for network slicing, especially using SR if you're not providing aggregation of some sort, the cross product of your endpoints versus the colors you're providing these things for can potentially be huge. So that I think also will motivate the question of what we do about namespacing. So again, summary, we're trying to provide a simple mechanism, very similar to 3107, 8277, for inter-AS carrying of colored labeled routes. We know that there are some considerations in terms of agreement and options that we can do if that ends up not being a good generalized solution. And past that point, we're looking for discussion and potentially adoption.
Yeah, Adrian Farrell again. So I'm glad you've recognized it's a hard problem. I'm not quite sure that you've recognized how hard it is. I hate to do the we've been here before, but we have tried this several times before. Once at least was MPLS traffic engineering. I'm sure you've got people within your own organization who were there at that time and can share with you. I'm happy to chat offline about quite how difficult this is, because it's not just a namespace thing, it's a policy problem. And
absolutely.
It's sort of order of n factorial.
It ends up being certainly
order of the power of n factorial.
One way to look at it, since these things are intended to be passed along interdomain, hop by hop, one of the things that this is a read between the lines in the current draft in terms of the recursive resolution properties, and since we have actually gotten challenged, we need to actually talk about this. This is what the working group decides they're going to go. The general idea is that when you're passing around these sort of abstracted versions of a color that you're using for interdomain purposes, on a hot-by-hot basis, you can use a attached color community to help you locally resolve, interdomain red to local blue, and those colors can be reset on the ASBRs.
And that works for sort of like the one dimension, but then there are multiple interdomain reds because each commercial relationship between the multiple operators will have different definitions of interdomain red, and so you need like a double indirection. Somebody tried a business model for this at one point, being a broker of this, and they burnt some money and then went away.
Yeah, unfortunately, this stuff eventually starts smelling like route distinguishers, and that's the encoding that we've discussed internally.
Ben Madison, work online. My point is similar to Adrian's. Yeah, it's a fairy tale that you could just agree on the values. Do I remember correctly that the actual namespace size is 32 bits?
32, yes.
So this is starting to feel fairly familiar. Can I suggest that we ask someone to write large colors?
That's certainly an option.
Because if we're going to try and use some sort of intermediate mapping that only exists in the kind of no man's land between two ASs, those are likely to be namespaced on the basis of an AS, and immediately we run into a namespace size problem. So my term large colors is kind of tongue in cheek, but it's almost exactly the same problem as standard communities.
Absolutely, and Adrian did bring it up correctly. So it's not even just pairs of ASs. This may be sets of ASs, and the sets of ASs may be different depending on context, and therefore you end up with all these different disjoints ideas of what things mean. Red may need to mean for Federation set A and Federation set B completely different things. You just need a way to disambiguate them. The question sort of comes back in terms of encoding. You simply make a very, very large global value. So do we move from 32 to 128 bits and assume that for all the disjoint sets we can come to some agreement out of that? My guess is probably not. And I think this probably pushes us more to something that looks like a route distinguisher in terms of you're able to set up for Federation A, namespace 1, red means this, and then you can disambiguate it with something that actually has a global allocation mapping.
Yeah, so I think probably the kind of the pairwise approach is going to be the best one. I think so I've done kind of the equivalent exercise to negotiate mappings for traffic classes and kind of option B and C VPNs. Usually what that boils down to in that context is someone gets to kind of own the namespace and the other person is responsible for mapping in and out of it. that's a hassle for the person that has to do the mapping.
Right.
So I think in this case, if we want to avoid that problem, what you want is a large enough namespace that you have a namespace per peer. You know, so in the context, so given AS1 and AS2 are interconnecting, they want a unique namespace to identify the mappings that exist on that adjacency.
So is it per adjacency you're talking about, or per AS adjacency?
Per AS topology graph adjacency.
Okay.
They
You're
may
using
be
peer
multiple
in the business sense, not the BGP router sense, I take it.
Yes,
exactly.
Right, and again, I believe this actually extends to the set of ASs that may be participating, because if you have ASs 1, 2, 3 in a chain that need to have this agreement, that's what you're worried about.
Yeah, probably from a protocol perspective, that's rare that matters from an actual engineering perspective, because probably those two links in that chain aren't actually being stood up at the same time. And from a practical perspective, you're needing to abstract the details, the one from the other anyway.
Right, and I think where the suggested encoding of using a distinguisher is sort of nice. It gives you just like for route targets, you have to pick somebody's AS to be the root of the namespace, and then past that you can namespace out of that. This allows you to map all the functional equivalence classes for the different agreed upon color into one place. And the fact that I think may be different than some of the other proposals. I'm a little rusty on some of my historical reading. The fact that these things can recursively resolve on a hop-by-hop basis and the ASBRs, via color community to their local tables, I think solves at least some of the older problems, in the sense that you don't have to worry about what does this mean and have this giant translation table. Your standard BGP, community policy applied to the ASBRs can do most of your how to map from the interdomain version to this domain's equivalent of it.
David Lamparter, most of what I was going to say has already been said. I'm not terribly operationally experienced, but I would believe most people will do this mapping at the boundary anyway. And I rather have a good way to make that work than try and do the generic thing.
Adam Simpson, Nokia. Jeff, I guess one of the things that occurs to me in this is likely what's going to happen if people are using SR policies for the slicing. They're likely to use binding SIDs at the boundaries, and to some degree, I think that helps us a little bit, doesn't it? Because when we enter into a binding SID, the binding of the traffic isn't based on color anymore; it's based on the label. So I would think that actually does give you a bit of a decoupling mechanism, right?
A little bit, but it becomes sort of an ad path type problem. So if you have in the topology that failed to show a red path across the top and a blue path across the bottom, that's interdomain to the same endpoint.
Yeah, at the endpoint, I guess there's something that pure transit in the middle. I mean, in theory, he wouldn't necessarily have to normalize to the colors at the endpoint. He could normalize to a different set of transport schemes. And offer binding. Anyway, just a thought with binding.
It's the usual mapping problem. Do you actually expose, for the same actual endpoint, more than one address, or do you provide different label stacks? The trouble is, if we look at something in terms of a BGP linked labeled unicast type encoding, the labels themselves are not a key, so that doesn't help you interdomain. So you need one additional thing. People think colors for these types of things for slices anyway, at least in that context. And for the important thing is, this is just an encoding. Color is a common scheme that makes SR people happy and TE people happy. It's effectively just a distinguished route distinguisher that you can use with policy. That's it. Okay. Thanks for the questions. We heard partially what we were expecting, that the simplified version was probably too simple. Our likely next step is to bring back the next version of the draft with the things that we had discussed in there, and then after that, look for adoption. Thank you.
Thanks.
Sorry.
Okay, no problem. Okay, hello everyone. I think I'm the last presentation, and for today's I'm Lilei, comes from Huawei. Okay, so this presentation is for BGP request for to controller to let the controller advertise candidate pass for SRT policy. So this is the presentation's title. And before I introduce the detail about the protocol encoding and so on, I'm asked to introduce the, let's talking about the motivation about this topic. First, in the left of the slides, we can see the head end of the SR policy can be informed by the various means, including CLI, netconf, PSAP, or BGP from the controller to get the SR policy and the candidate pass. This all defined in the Spring's draft SR policy considerations. So, but when we can get all this information from the controller, sure, we can get all the SR policy tunnels, SR policy entries from the controller at the beginning of the VPN created and initialed, but it's not so friendly for the small boxes in our network. That means if we can have a trigger method, trigger mechanism for the head-end ingress of the VPN or the head-end of the P to get the SR policy and the candidate pass from the controller on demand is better for the small boxes of our in our network. So in some situations, head-end may want to pull one or a set of candidate paths from the controller or PCE rather than just get all this information at the beginning of the VPN initial. So if we can know PSAP, this protocol has defined the request and the reply messages in RFC 5440 to match this requirement. That means they can ask PCE to give them the S list or candidate pass or the anything else from the controller when he wants. But I'm also to say we use BGP from controller to get SR policy and candidate pass, but BGP's update message or some other messages cannot to request this one. So all this document I defined to find a mechanism for BGP to similar with PSAP to get the request from the controller to get the candidate path to get the SR policy. So we can see in the right of the slide, that means when the head end maybe got some special prefix with special attribute or special colors or anything else, this is an event to trigger the head end can request as a policy from controller. So the second pass is like that, but the third pass is from the controller to download the policy or candidate pass to the head end. So I have different colors with the step 1, 2, 3. That means actually this document just defined the step 2, but 1 and 3 is already exist. So this is just a brief of the motivation. And this is a little detail about the process and to talk about how about the scope of this document, which one is inside this document, which one is out of the scope. So the first step is the head end to decide to get a new candidate path from the controller based on some trigger event, such as I have said, receive some special customer routes with a special color, with special attributes. It's just an example because the trigger event, the trigger mechanism is out of our scope to define. Actually is for more like a configuration or more like an engineer to decide to do it, to pre-configure it. So this is out of our document, but the step 2, the head end when decided to ask this information, that means that he will create a BGP update message. This update message's encoding is no any changes, but we add some new sub Tlvs for the constraints for the compute constraints. So this is inside of our document defined, and the step 3 is for controller to receive this all constraints from the head end. They will calculate the S list, segment list with these constraints, and then to download the SR list to the head end. And so this is step 3 and step 4. All this 1, 3, 4 is out of the scope of this document. Some is defined in IDR draft, some is defined in Spring draft. So this is just for the step 2 BGP update message for some constraints to ask to the controller. So actually it's not very complex for this document. So this is for the encoding of the update message and some new sub-TLVs. Updates messages follows for the existing IDR draft segment routing T policy. That means SAFI, RI, and policy color and point field, anything is the same. We just give a distinguisher with a special value with OF to tell the controller it's a request. It's for request. It cannot be used for pass select or anything else. So this is a little special in this field. And we add 5 new sub-TLVs for the candidate pass constraints, RSP attributes, SV vector, metric, IR, and load balancing. These 5 sub-TLVs is for constraints for the pass calculate. So this is a little different. I don't write too much things in the slides. You can read in our document. I just to brief to say how about this TLV's constraints. First one is for the RSP attribute. Actually, is for the affinity. We all know in PCE and so on, we just link affinity and color to match whether this pass will follow some affinities. So the first sub-TLV is for the RSP attribute for affinity. This always actually defined in our PCE RFC and 320 and 5440. And the synchronization vector, this is for the to let head end to ask this all as lists whether have some so for link device, that means this all segment list must not with the same link in common. Node devices means without the same node. As our risk link group, that means will not share the same link, some risks link group. So this is for to let controller to compute all the segment lists between them to link device or no device or some risk link groups. Okay, so this is the second sub-TLV. And third TLV is for metric, actually for the segment routing. Actually, this is more important for the this T bit with 11 is all defined in our PCEP segment routing draft to let controller know how maximum as seed depth should be calculated. If exceed the maximum seed, that path will not be established. So this is just for the metric and the seed depth to let controller to compute the path. And the fourth is for IR. That means include root sub-TLV. That means to let controller know if the path must be travel with some node, some seed or NAI, and all this detail defined is all defined in RFC in the PCE. In the segment routing and so on. So that's almost the same, but it's defined in our BGP message. So last one is load balancing. It's a little different in our as a policy. It's just because we have some weight for different as lists. So here we define a load balancing sub-TLV with maximum as list. That means to let the controller know how many as lists should be included in one candidate path. So this is the last TLV. So actually, this old message TLVs in the update message is just to let controller to compute the path, the as list with some constraints. It's no other no other things. So some details should be in our document. So this document is very simple for to understand, just to let friendly for our small box equipment in our network, to let the SR policy tunnel entry not too much for the small boxes, just to trigger the on demand to get the SR policy tunnel entries in our equipment. So the scalability, the performance is not very high. So next step is just to see any other comments about this and to revise our draft accordingly. Okay.
Were there any questions either now or remotely?
Ayana from Twitter. One question I want to make clarify. What is the reason? Yeah, I think kind of scenario can be covered with PCAP protocol. You know, it is right right task for the PCAP protocol. So what's the reason you make expectation based on the BGP?
Yes, yes, I agree with you with PCAP. I said we have the request and the reply messages can do that. But let me see about the PE head end. That means because as our policy, we have already defined from BGP from controller via BGP protocol from controller. That means the head end already support BGP. But now if you think, okay, I need to PCAP. That means that equipment we need to support PCAP also. I just say if for the small boxes, if we can unify the protocol, it's more easy for operator. I don't say it cannot do. I just say it's easy to operator. We can do it. It's an option if like that. Also, you can use PCAP. I agree with you. Just to let this boxes, I have said it's friendly for some small boxes in our network. I don't say we cannot do it. I just say it's more friendly for this equipment. Yeah.
Stefan from Orange, please use PSAP to do this. You are replicating everything which is in PSAP. Just use PSAP. BGP is a distribution protocol. It's not a request and then send me just something. You are completely changing what BGP is, so please use PSAP.
Yes, I agree with you. Totally agree. But again, I must say, if the step 3, I have said, because we have defined IDR draft to use BGP to send candidate paths from controller to the equipment. But why at that time we don't say, okay, PCAP can do it. Why we use BGP? I just to say, because we have defined some mechanism with BGP, so we must to do something to help this BGP can do more other things for the equipment. I just to say it's an option. Yeah.
Andrew here. I'm looking at this and I know there are a lot of people who'd like PSAP. I personally would ask you, why aren't you using gRPC for this, which is used everywhere? I mean, but basically, why wouldn't you use anything other than BGP for this? Because, you know, as someone else said, the BGP is there for distributing information, not kind of requesting config information. And if I'm going to request config information or something, then gRPC, PSAP, anything but.
Yes, I agree. I totally agree. Because we can master to say something like here. I have said in this existing draft, we defined yes, gRPC, yes, netconf, yes, CLI, yes, BGP, yes, PSAP, everything is okay. So at that time, we don't say why you use so many methods. Why not? So till now, because we can get it from BGP. So now we defined a new mechanism to let the BGP can get a request. I think it's more easy to understand. Yes, I totally agree. netconf, okay. CLI, okay. BGP, not PSAP, okay, no problem. But I must say, BGP should also be okay. It's like that, yeah. Just I don't say anything else. I'm sorry.
Okay,
Yeah.
we like BGP.
Yes, we like BGP. It's just a protocol. Yeah.
This Robin from Huawei, seriously, I think that we face some of the scenarios. There's now that they always use the BGP instead of the PSAP. And maybe you understand the data center network. Here, there's the fact is not use the PSAP, but the BGP ISR policy is introduced. So I think this is a possible way to unify the protocol to request the candidate path and to download through BGP. I think this may be convenient for the operation. That's the purpose.
I see someone standing. Is that from the lengthy discussions, or did you want to make a comment? No. Okay.
Feel free to take a 7th inning stretch. It's okay.
Okay.
Maybe some other comments, please, from mailing list. Thank you so much.
Okay, I've got it in just a minute. Well, that's interesting. Okay. That's new. How did I
You
get?
need to get that little Zoom button.
I did. That's why
There we
it's
go.
interesting.
There we
Okay. Here we go. Okay, that warmed us up for a good set of discussions on the charter. Thank you very much. Okay, this is going to hopefully be feedback time for the chairs. First of all, I've been sending statuses out more frequently, every 2 to 3 weeks or so. Little hum from the room. Was that a good idea? Was that a bad idea?
Jeff Hayes?
Oh, you can't hum. Not a hum. Okay. Folks,
No,
tell me,
hum for is that helpful?
is that helpful?
A quiet hum. Hum for don't waste your time, Sue. It's okay. We don't need it.
Well, that's a
Okay,
silence.
Keep doing it.
Keep doing it. Okay, that's it.
So if I could, so Jeff Hayes, I love the status. It shows us where we're at. Having everything in one message means that threads that get kicked off of that are hard to follow. So you have 16 things inside of a status item, and then we end up with all these discussions around it. When you go to look and see, do I care about this thread? Don't necessarily know.
So the suggestion
Okay,
is to
and-
microfragment the status down to status on each individual work item?
Not quite that bad, but it's a little hard to follow.
Or is the suggestion that people following up should create a new thread?
That would be helpful.
So Jeff nods yes.
Jeff Haas, got it. Okay. This has been on the list. New charter talks about what we expect from peer working groups, what they can expect from IDR, and removes the old crufty stuff that was in there. If it passes, then we're going to update milestones. This is just to give a bit of a discussion going. So this is the charter text. If anybody has questions, John sent it out. Mostly we got +1s. If you have any questions, I'll cycle through this. If not, we'll go to the thing that John and I would really like, which is tell us which is the next important thing to do here. So we can.
Yeah, and Alvaro, I don't see you standing up, but you had unicast us, I think, some comments. Do you want to provide them at the mic, or we'll just take them later? Okay, yeah, I think you might have been typing in your sleep or something, so we'll just take it later.
Okay, comments.
Yes. So speaking as best working group co-chair, I would like just to know why you added more text about the relationship between IDR and the other working groups. Have you seen some issues or?
Had requests from other people.
Sorry?
We had requests from other working groups. We may already work well, together,
Yeah.
but other working groups asked us to add it.
Because in my opinion, the job of IDR is really to create the base infrastructure for BGP and define all the guidelines for other working groups to be able to use it. As far and as long as we are within these guidelines, I think we don't really need a kind of review or something, but sometimes we are a bit borderline and we need more extension to BGP. And in this case, of course, you need to be contacted and probably some work need to be done within IDR, but I just want to avoid slowing down some work we could have if it's just really very simple things that we need to add, like just a new extended community or something.
Right. So that's the intent of this. What you just said, I couldn't agree more. And that's what we tried to write in the charter. If you think we missed that, and created like more process and it's going to be a problem, that's exactly the kind of feedback we need to hear, and we should iterate until we describe what you said.
Yeah, the way I'm reading
might-
it is that for each code point that we need to allocate, we need an agreement from IDR.
Okay, what we tried to write was for each code
Should
point
be
you're gonna have-
consulted, talked to.
Let me give an example of a place where I want IDR engaged heavily and an example of a case where I don't. So a case where I think that IDR should be thoroughly engaged is if you're creating a new path attribute. An example of a case where I'd like a single message to the IDR mailing list is if you're allocating a new well-known extended community. And it's not a blocking email to the mailing list. It's just a hello.
Okay.
That make sense?
Yeah. The other point is about the exact scopes that IDR is dealing with about the AFIS. So the current text that you are displaying is telling about, okay, we are managing IPv4 and IPv6, so internet. Is that the exact scope that you are limited to? Just to try to clearly define the boundary between what you are doing and what we could do in BES and so on. Yeah.
I would say that is not intended to be limiting. And in fact, the text is right now written in a way that it's not intended to be hard scoped. Because people bring new stuff along and we'd like to at least be free to consider it.
And there's good reason to be in various places. We need to have as many threads through this as possible to get the workload through. So not intended. It's just something we can fix.
Okay.
So, that said, for example, I have no intention of trying to define VPNs here.
There are some things that would be good to consult as we do the new tunnel attribute. We've got to figure out how we transition things to the new tunnel attribute from the extended community. What makes sense? That's a discussion. There's a lot of play back and forth where things are deployed, where things are not.
Yeah.
Let's be sensible. Let's get the code that's out there and not block that. So this is not meant to do. That's another example where we're really trying to be reasonable and.
Yeah, because for this kind of example, so the tunnel on caps, we are still in a kind of transition period. But
Yes.
as soon as we are in a more future where the tunnel attributes will be maybe always used, why do we need IDR support to just allocate a new type?
Right, that's the point of saying just send us an email.
Alberto with Routing AD. So just to be clear with you, you're doing nothing wrong necessarily. What we really want here is there are many working groups that work on BGP stuff. We just want to make sure that we know what's going on. So yes, we don't want to slow everything down where IDR and the other working group and everyone else has to approve everything. We don't want to do that. Because if we wanted to do that, we would just close everything else and just do everything here. And
But we
I don't
went the
think
other
anyone
way.
wants to do that. So all we want is, just information. It may be that there's something that you think is really important, and IDR says, "Oh, okay, thank you for letting us know." And, that's it. It may be the other way around, where you inform us of something that is routine, and someone says, "Oh, but that's really important because it changes something." So that type of information. And that's it. We can go from there. And when we say we, I mean the chairs can coordinate from there if there's anything else needed. But the base is information.
One really good example where we did some good collaboration even this week is in the IPsec stuff. That was really, that session brought up lots for the best, lots for where the proposals that came to IDR, where the good stuff, that's more of the stuff we'd like to see. Okay. And, you know, we welcome requirements. Don't just send, you know, stuff back and forth. If you think we should be doing something, tell us. Okay. Anything else on the charter? Great comments. Okay. This picture these are the issues that people gave me on the list. I tried to send it out this morning. That's a long set of issues. Okay, what some people told me is I tried to give snapshots and summaries, but some of them weren't really terrific. So I've left the issue list, and we can start with, yeah, let's just go and tell us what the top issues you want to try to work on, or I can delve down a little bit into issues that are interesting. They're on the slides. You can look at it. The only thing I think we'd really, and I've started working group last calls or adoption calls in several of these places. The only thing I'd really, might be really interesting to go into in detail is faster registry handling, but because that could snarl us with a lot of process discussion, I wanted to make sure we got to the meat first. Anybody want me to dive down? Is this the time to ask questions? So dive down, what is the right thing? Come to the mic if you want. Come to the mic if you'd like me to dive down into any of these. Tell me which one.
Yeah, I mean, you've talked long enough that people have had a chance to read the list, and you know, if there's one there that they want to engage on, now's the time, and there we go.
So in case any, Albert in case anyone didn't come to the other meeting on Wednesday, what we talked about there is that what we want to do is produce a general charter. Now, this is what IDR does, coordinates with other working groups, you know, et cetera, so that we don't end in the same situation that we are now, where we have a charter that lists a bunch of stuff that we already finished, some things that we are never going to do, and we're actually working on stuff that is not really in the charter, that we're just taking on because, you know, it's the right thing to do. So that we don't recharter every other year, we want to just manage, and when I say we, as the chairs are going to manage, the flow of the working group based on milestones. So what we're really looking for now is talking about, okay, there's a list of issues. What are the issues that are really the priority for the working group that we should put first in the milestones so that we know that those are important and work on those? And then the chairs can manage by using that as, okay, this is what we're going to process first, et cetera. We can also measure later and discuss, have a more dynamic discussion, maybe not every other year, but I don't know, whatever, once a year, whatever it is, that we can add things to the short list, remove things, I don't know, figure out whatever it was. So instead of having 27 things like that, it would be nice if we knew what the working group wanted to focus on.
Right, and I mean, it would be great if, you know, if people have well thought through ideas on this now that they want to share, super. But otherwise, if, you know, blood sugar is running low prior to lunch and you're tired after a long week, really the more important thing to do is, you know, as you're traveling home, you know, next week, whatever, let's have a real discussion on the list about prioritizing our milestones. But I don't think we would, you know, even if we said, no, we're going to use our next meeting slot to do milestone prioritization, it's not like it would conclude very successfully, I think, in one meeting session.
AC Linda, Cisco Systems. I just wanted to say over the last month and a half, I've seen a significant uptick on addressing the things that needed to be addressed, that really, you know, were blocking documents like the tunnel end caps and other things. And I think getting some of the work done where there are implementations, you know, and a lot of that, I realize you don't have power. You can't make people interop test. You get one implementation. You can't make somebody do another one. But I think I've seen, it seems like we made more progress in the last month and a half in the preceding 4 months.
Thank you. Thank you, AC. We've been trying to do that. Been trying to push. John, should we cover the fast registry stuff? You got that one. Let me get to it.
So I don't think this should take too long, but it apparently is my destiny to talk about registries like every meeting. Okay, I'm just, yep, do a little soft shoe. Nope, that ain't it. Here we go. So let's see. I'm just going to go ahead and talk about early allocation. So you know that over the last few years we are have continued to try to improve our sanitation in terms of how we allocate code points. Part of that is by really trying hard not to have people squat on code points, including by publishing them, just picking them out of there and publishing them in their drafts. So, that's the stick half of it, but we have to provide a carrot half also, which is to have a way of giving you code points easily when you need them. And I'm not going to repeat why that's incredibly important. One of the tools that we've tried hard to use for that is early allocation. The early allocation policy is a thing that says, look, if you've got a draft that's sort of progressing towards becoming an RFC one of these days, you need a code point in order to get your implementation done so you can actually show some interoperation. We think that's great. We want to have a way of doing that before you get your RFC number so that you don't get stuck in a chicken and egg problem. There's a RFC that says how to do this. It's got 4 criteria. I'm not going to read them all to you because the first 3 are things like, is there a spec? Does it make sense? Stuff like that. And your chairs are willing to take on the duty of saying, clearing those 3. The 4th is one that we have in the past construed as meaning it talks about interest in the community. And, we've said, well, we have a consensus process that we use for a lot of different things, and let's use this for sort of judging interest in the community. And that's resulted in, we need a consensus call on early allocation of thus and such. And that adds at least 2 weeks of latency. I mean, if we're really on the ball and we fire off the consensus call right away and we conclude the consensus call right away, which, as you know, we don't always do. And I was talking with Alvaro the other day, and he basically smacked me around and said, John, you already have gone through a consensus process to adopt a working group draft. Explain to me why that doesn't mean you have community consensus already. And I sort of hemmed and hawed, but really he was right. So the proposal is that going forward, what we're going to do is, if you have a working group draft and, authors and implementers come to the chairs, come to the working group and say, yeah, we want early allocation, we think it's time, that we are going to believe you. And we are going to believe that we've already got community consensus and we're just going to process it forward. We'll, ping the list and, we'll expect this all to take place in public on the list, of course. But instead of saying, you have 2 weeks to get your comments in, we're just going to say, we're doing it. And if you wish to scream bloody murder, you had better take it upon yourself to do that. Otherwise, we'll just proceed forward, allocate the code points, and go on. Of course, part of the reason that you have humans as working group co-chairs and not automation is so that we can exercise discretion. So, we may sometimes exercise discretion and say, you know what, yes, your draft is a working group draft, but it's actually been 5 years since it became a working group draft, and we're not really convinced that anybody in the working group is paying attention anymore. We really need to, actually do a consensus call on this. But in general, the proposal is that we just kind of speed things up on early allocations. So, pros and cons, I think I covered them already. If you have any opinions on this, please provide them, especially if you are opposed to it. If you're in favor, I mean, attaboys are, plus ones are all very well, but mainly this is to give you an opportunity of saying, to say, no, please don't do this, because we think that the 2-week consensus call was a valuable gate.
I hear silence. There is one other slowdown in your last one. That was my error. I think I tried to tell that out in the status. I will be tracking any early code adoption you requested. If you thought you had it and it isn't in the registry within a week, please send me an email and I'll go track it down.
Oh, and I did promise to come back and say specifically as regards to the BGPLS registries, Adrian has been so kind as to write a short draft, which the BGPLS registries were kind of neither fish nor fowl. They're designated, specification required, which according to Hannes, he always thought that what that was supposed to mean was just an internet draft. When you go and actually read the relevant RFCs, it really doesn't mean that. And so essentially Adrian's draft more or less tries to move it into just have an internet draft. Is that pretty accurate? So if you have, obviously, as with any other document destined to the working group, if you have some opinions on that, please provide them on the list. And questions?
Rüdiger Volk, Deutsche Telekom. Just one simple question for the early allocation for figuring out what how much value the 2 weeks waiting time has provided so far. Do you have at hand, or could you just check the statistics, how many early calls we had and how many actually resulted in something where the waiting time actually
in the last I'm just going to give you a rough estimate. But the rough estimate is we had at least, my guess is about 15 to 17 calls. We had 2 that people asked questions that I simply had to follow up. All the rest were +1s, support, snore, but 2 had some comments. Those also could have come up in the working group adoption process instead of having +1s there. So
yeah. Well, okay, kind of. I could imagine a situation where I did not take the chance to oppose the adoption and then feel bad about the early allocation, but that's not really relevant. So I gather you are saying essentially, yes, there has been some discussion, but actually the decision to do the early allocation actually never was denied.
Correct.
Hi, Ketan Talaulikar, Cisco System. So for the BGPLS thing, as an implementer, I think I definitely would like to have a specification required and not really fall back to the experts review, because experts review doesn't need a specification, I think.
So you should read Adrian's draft. That is not the case.
Yes, I understand. But the other point that I wanted to bring was the contention was because internet drafts are called temporary. And that's where we thought that, they cannot be used as a reference for specification. Can't we just, do an update or something on 8126 that for the purpose of specification required, internet drafts are not temporary?
So IDR is not the correct place to update 8126.
But I was, yeah.
Just really quick. Ayana is actually working on an update to 8126. So if you have suggestions, please talk to them. And the other thing I was going to say is that expert review doesn't necessarily mean that the expert does whatever they want. Ideally, and this is in 8126, it says that the RFC should provide guidance to the experts. So if you want something specific for the experts to do, For example, deny anything that comes from Adrian. You can put it in the RFC. And, whatever the working group wants, including the expert can consider or should accept internet drafts.
Because Keaton, read the draft. As Alvaro says, there's direction to the experts, and the draft that I've written says that requests that come from the IETF must have an internet draft. To your point, and updating 8126, yes, talk to Ayana, but calling black white will not change the nature of black. An internet draft it may be archivally available, but it is not a stable reference. So if what you want is specification, and I hear that, if what you want is specification, then let's stay with specification required, but ask for a specification. If what you want is internet draft, then let's loosen it a bit and direct the experts to say an internet draft is good enough.
Yeah, sure. I mean, I'll defer to Adrian, knows better.
Loa Anderson. I have a question on how to read this, really. You say adopt this approach, and that is fine, I think. You can, as a working group chair, take the decision. You can judge that there are consensus at any time. The experience I have is that sometimes I can do that. We are close to working group adoption, we had good discussion, and yeah, just go ahead. Other cases, it's a kind of 6 months later after the working group adoption, discussion has been kind of weak on the list and I don't really know. Then I do the 2-week poll, or if I'm somewhere in between, I do a 1-week poll. So you should be allowed to do all those things to have enough information to judge if there is consensus to actually do an early allocation.
Okay, thank you. Yeah, I think that we're in agreement that, and really the purpose of putting up these slides and talking about this is because, we have, through our behavior, trained the working group to expect, one set of procedures from the chairs, and now we're saying, no, we're going to change it a little bit, like Loa has described. And, just please don't be surprised, and if you, have concerns or whatever, let us know. That's it.
So also I think that the way you decide that you want to judge consensus is probably very close to without appeal. You decide how you want to do it, you do it that way, and you get the information you need. What I'm saying is, if you are sure there is working group consensus, well, just go ahead. If you want to do a poll, do a poll. Or if you want to use some other method, do that. And it's sufficient. You decide.
Thank you. And we are now 2 minutes over, but I don't feel guilty because we're canceling our final session. And let's get out of here. Hope to see you in Singapore. Oh, and if somebody has the other blue sheet, if you could wave it around, bring it forward, something like that, it would be helpful. Thank you.